in terms of the history of agentic AI systems, essentially the main sort of four buckets I would group them into would be RPA, robotic process automation, supervised machine learning, generative AI, and agentic AI. So in the RPA era, which was a bit before my time even, essentially you had like a process workflow and you had some data. And you wanted to build an agent that could basically use those two data sets. And it was quite a simple approach. And yeah, as a result, it was fairly like rule-based almost. Then you had the era of sort of supervised ML, where you had some training data, then you had a machine learning model trained on top of that, and then it would do some sort of prediction or classification task. Now, more recently, we had generative AI, where you can give it a prompt, then there'd be a visual language model or a large language model, and as a result, it would generate text or images or videos. Fourth and lastly, you have agentic AI systems. Now, this essentially starts with a goal, and that can be expressed as a prompt, but it typically will fetch some data and will do some planning. It will then potentially do some actions, integrate with some systems, maybe make some purchasing decisions, workflow decisions, and then learn from that, reflect, and then make a response. Now, there are quite a few different types of LLM-based systems. A lot of us have worked with systems where you have an input, a large language model, and then an output. That's like your ChatGPT experience, let's say, or your Gemini experience. Now, you also have a scenario where you can have a learning agent that performs some actions in the environment, and then based on that, those actions in the environment, there are observations that go back to the language agent. And then another sort of more recent one is essentially that formulation where you have a language agent making actions in the environment, but then also it retaining some of that in its own memory, which is a really, really interesting part about agents that can learn for real based on the context it has been exposed to. And that can obviously be the context of your business data or your business processes or your product features. One of the approaches that has been quite influential over the years in terms of understanding how people think, so human cognition, is known as a common model of cognition. And that consists of essentially quite a few simple bits and pieces. You have essentially long-term memory that retains, well, essentially things that you want to remember over longer periods of time. Working memory, things that are kept in memory for doing tasks then and there. So if you're essentially doing like a very simple task like analyzing some data, you might want to know what the goal of that analysis is, what data points you're looking at right then and there. And then also procedural memory, which is another type of long-term memory, to ensure that there are specific, almost like scripts or schemas that you can follow based on your previous experiences that have been shown to be very, very beneficial in these contexts. So essentially, this provides a bit of a baseline of what AI agents could be based on, given that human memory works in this way. And this is like one of the sort of metaphors that a lot of people are using to train AI agents. Now, if you want to deep dive into the details of the Common Model of Cognition and its implications for AI agents, I recommend two papers that you can kind of go into. They're both about the cognitive architecture of language agents, and they draw parallels between human cognition and what it means for AI agents. And it goes into details around perception. So the perception being in CX context, what are the data sort of assets it has access to, as well as memories it can form and the actions it would take, as well as architectural learning. So what are the kind of things the overall agent should learn across different contexts? So yeah, these are the papers I'd recommend if you want to deep dive into this topic. There are many different types of memories, both in humans, but also in AI agents. And I think over the next few years, we'll see a plethora of different memory architectures and agents. But using the human sort of common model of cognition as an inspiration, researchers at Princeton, for example, have highlighted 3 distinct areas to focus on: procedural memory, semantic memory, and episodic memory. Starting with procedural memory, it's really just memory around the sort of how-to of something. And this is essentially a set of skills that can be stored almost as scripts. And semantic memory is a bit more complex, and it's really around the associations and over time that someone's exposed to and learns, from the visual environment, linguistic environment, etc. And then finally, you have episodic memories, which are memories around specific experiences. And agents will also have very specific experiences in many different cases, right? And all these will interact with memory in slightly different ways and will have different strengths depending on the context being required. So, my particular memory around how to behave in a formal dining scenario might not be as critical when I'm doing some mathematical analysis, right? And vice versa. So like in human memory that looks at what is relevant for a particular context, these AI agents will also be able to sort of fish for the relevant memories and the relevant recipes, so to speak, in different contexts. And that will ensure that the insights these AI agents unearth are much more relevant than they have been before. Now, to bring this all together into a generic agent framework that simplifies many of the points we've talked about earlier, essentially you can think of an agent consisting of memories, both short-term and long-term. The long-term memories being essentially all its recipes over all of its interactions, but the short-term ones, or the working memory ones, are the ones that it needs right now. A bunch of tools that are useful for a bunch of different actions, from, let's say, charting to performing deep statistical analysis to many other things. Actions it can take, like communicate insights in different ways, as well as plans like, maybe a more sophisticated analysis needs to be calculated to then perform an action more relevantly. So yeah, essentially you can think of an agent having memory, tools, plans, and actions.